Hi, this is Kevin. Welcome to my tutorial for Zelle, Chapter 8, Exercise 4. This is one of 4 custom exercises that I put together, so it's not in the book. You'll be happy to know that the demonstration that I'm doing here in the tutorial is the exact same thing that you're going to be doing for your exercise. This is all very demonstration oriented, and just simply typing in the demonstration and seeing it work is the whole objective. One of the challenging things about Boolean logic is that you don't get it till you get it. It was particularly easy for me because I was learning it in a logic class at the same time I was learning it in a programming class. Maybe I was a semester earlier in the logic class. But when I got to programming, I said, hey, it works just like plain old symbolic logic. Well, if you don't have that background, you don't have that benefit. And how did I really come to understand it in my logic class? Well, we have these things called truth tables, and they show all the permutations for 2 possible statements that could be true or false. And then, so for instance, the truth table for P and Q, which is given in our textbook on page 247, it has a column for P and a column for Q, and we see all the permutations of which one's true and which one's false. And then there's a column for P and Q, and what we essentially find out is the only permutation of truth and false in P and Q. The only one it's going to lead to P and Q being true is when they're both true. And you can see that in the table in the textbook, and we're going to print that, and you're going to see how it works and probably a little bit of why. Then we're going to do the truth table for P or Q, and then there is over on page 251 at the top, there are these De Morgan's laws, and these are kind of easy ways to simplify expressions that we're trying to not. So if we're trying to get the opposite of an AND expression, we can use this version 1. I don't think that anybody calls them version 1 and 2 except me. Okay, so those are not terms of art. But the first one tells us how to negate a P and Q, or how to negate a P or Q, and it gives you some opportunity to simplify the expressions that go in your whiles, that go in your hanging off of your ifs, hanging off of your elifs. Okay, so and we're just trying to kind of get the way this works through demonstration. So here we go. Let's get started with main. So let's have a def for main. All right, and let's just say pass. That won't complain at us for a while. And have an invocation of main, a call to main. Okay. So what's the first thing we want to do? Well, let's print a polite message. And I'm going to say demonstrate Python Boolean logic features by printing truth tables. How's that? Okay, that looks good. That's a sentence. I'll put a period at the end, I think. All right, and I want a blank line after that, so I could have another print, or I can end this with a \n for a new line. Let's just do that. Okay, that looks good. All right, let's test that. So we're going to test it, and There we are. Demonstrate Python Boolean logic features by printing truth tables. All right. So let's go down. To make this easy, what we're going to do is we're going to create two lists. One, we're going to list the possible values of P and then the other the possible values of Q. So our variable in the program is going to be called small p. Okay? Because variable names are typically lowercase. So P equals, and let's do this, true, false, false. Okay, so that's a list, and it's got 4 values: true, true, false, false. And we're going to do the same thing for Q. So we're going to say Q equals true, false, true, false. Now these turn out to be all the permutations. We've got the one where they're both true, we've got the one where they're both false, we've got 2 where they're alternately true and false, but they're the 2 different combinations. Okay? And if you look at the truth tables in the textbook, you'll see that those are, the rows that we have. Okay, so this is pretty straightforward stuff. So the list, we've got 2 coordinated lists, and that's going to allow us to go down a for loop where we say for variable name in range 4, and then we can see these 2 values together, these 2 values together, these 2 values together, these 2 values together. Okay, let's see what that looks like. So let's come down here and let's print the heading for the first of our truth tables. The first one we're going to do is P and Q. Okay, and now P and Q are statements. Okay, in Python they would be logical expressions. They could be things that we're either going to evaluate to true or to false. Okay, you can think of them as sentences in a logic sense. They're some kind of claim. The sky is blue, the earth is square, those kinds of things. But in our case, they're just going to be parts. They're going to be Boolean expressions, and they're going to evaluate to the values that we have right here. So we're going to see what happens when they're both true, when they're both false, and either version of one true, one false. Okay? So, and we're going to, the variables are going to be called little p and little q. And in the textbook, they use this more philosophy-oriented or logic-oriented way to deal with things where P and Q are capitalized. So when we print out the titles here, we're going to use capital P and Q, but the variables are going to be lowercase p and q. And that'll help us to tell the difference in our code between the text strings that we're putting in just to print the literals and the real Python code that we're putting in that we want to have evaluated by the Python interpreter. So let's say truth table for P and Q. Okay, so that's P and Q. Okay, so how are we going to do this? Well, let's say for I, we need some kind of index variable for I in range 4. Okay. Now, I guess I could have said, I could have tried to get the length of one of these things, and that would have kind of worked out okay. But they're both 4 long, and I didn't want to treat one any more especially than the other. Okay. And then let's print this out. So we printed out the title. Okay. And so let's do this. Let's print this. Let's print out a title for P, a label for P colon, and then the value P. Okay? And it's going to be P sub I, P index I, right? Because it's the one for this particular entry in the table. Okay, and then we're going to print out Q colon. Oh, I think we want to separate these. How are we going to separate these? Let's separate these with a regular old forward slash. Okay, so we put out the label for P, the value for P, and now we're going to put out, and then a slash. Then we're going to put out the label for Q. Okay. And then a value for Q. And again, because it's a member of a list, we have to say, well, which index? Well, sub I, we're in a for loop. Okay. And then let's put a separator in. Okay, a forward slash. And now we want to do P and Q. Okay, so we need a label. So we're just going to say big P and big Q, colon. Okay. And then we want to say we want the Python expression for that. So that's going to be P index I. Sorry. Use the wrong kind of brackets. And Q index I. Okay. And that should do it. Okay, so what we're expecting to do is we're expecting for the first row we'll get true true, so we'll get P true, Q true, P and Q. Well, P and Q are only true if they're both true. Okay, in that row this is going to print out to be true. Then we'll go to the next row. Okay, so P is going to be true, Q is going to be false. So we'll get P true, Q false, P and Q, well, this is only true if they're both true, so this one's going to turn out to be false. So let's give it a run. Let's see if it's actually working like that. Let's run. Let's see what we got. Okay, so the truth table for P and Q should only be true if both P and Q are true. And you know what? It's just like the one in the book. It's only true P and Q, the expression P and Q is only true when P is true and Q is true. Everything else turns out to be false. Just like the one in the book. Okay? So you can believe the rule, or you can just believe your eyes, because that's how it works. Okay, well that's not too bad. Let's see if we can, the next thing we want to do is we want to construct a truth table for P or Q. Okay, well, being the lazy lout that I am, I'm going to try to clone this. Okay, so I'm just going to skip a line in between. And let's see, how would I change it? Well, I want the title to say P or Q. Okay. And I want the label on the line to say P or Q. And of course, I want the Python code that really is getting evaluated to have an or in it instead of an and. And that should work. It's that easy. So let's give that a run. Okay, now here's the problem. I don't like it that these things are not separated from each other. So let's just put, and right before this truth table for P or Q, let's put a \n in the beginning of that title and run it again. Oh, that makes it easier to read. Okay, so if you happen to go to your book, you'll see on page 247 the truth table for P or Q. There's only one row where P or Q, the combination expression P or Q, is false. And that's the last one where they're both false. So let's see what happens here in our program. Well, guess what? The same thing happens. We get true, 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 false. So it's false when P is false and Q is false. In any other combination, it's always going to be true. So again, you can either believe the rule that P or Q is only false when P is false and Q is false, or you can believe your eyes. Okay? It works the same way. This should give you confidence that the rules actually work when you work your way through them. Okay, now for a little more challenge. Let's do each of these De Morgan's law examples. De Morgan's law says if you have a compound expression like PNQ or P or Q, and you want to take the negative of it, sometimes it's easier to simplify this and express it another way. Okay? And we're saying of each of these examples here, this is the first one, or the second one, you can go from one side to the other and convert them if you think it's going to make more readable code. Okay? So for instance, if it makes sense you just say not P and Q, well, fine. That's fine. You could stop there. But you're going to say, no, that's a little backwards of the way we want to say it. Well, you can automatically, convert it to not P or not Q, and you get the same answer. Why? Because De Morgan, however many hundreds of years ago, he figured this out. And of course, the opposite is true in version 2. If you have a case of not P or Q, well, then you can change it to not P and not Q. And again, you can go from one of these sides to the other depending upon what you prefer. It's not the case that one of these sides is good and the other is bad. It's a question of being able to convert from one expression to the other depending upon which you find more favorable for the readability of your code. All right, so let's get working on the next one. Okay, so let's do the first of the De Morgan's laws. So let's say print, and let's start out with a new line, \n. And then let's say truth. Oh, I guess we should have put this in a character string. Truth, sorry, \n. Truth table for De Morgan's law first version. Okay. All right, that should look good. And what do we want to do? Well, let's see. I think we're going to want to do the beginning of this. So let's copy this. Let's see if we can copy this for a bit. Okay. because if this is a truth table, we have to say, well, what's the value of P? What's the value of Q? Okay. And then I just wanted to show that these two are equal. Then I'm going to print out first not P and Q. And then second, I'm going to do not P or not Q. And we're going to see if those expressions are equal. We should get the same answer for both of them. Okay? If one's true, the other should be true. Okay, so let's do this. So the label is not P and Q. Oh, sorry, not P and Q. That's the label. And then what's the value? Well, let's say not P and Q. Okay, it's that easy. All right, that's looking good. I guess we still don't have our end parenthesis. Let's get our end parenthesis out here so it stopped complaining. Okay, not P and Q. And of course, we're going to want another separator here. So let's put a separator in. /. Okay. And let's see what that looks like. Let's just get the first one up until we need another one to compare it to. But let's just see what that looks like. So let's print. Let's give this a run. Okay. So we say if P is true and Q is true, then not P and Q is going to be false. Okay? And now we're going to figure out what the next one is. So we'll figure out. Oh, and I'm thinking that because we have a colon after each of the labels, we ought to put a colon here. See how that looks. Okay. So let's run this again. Okay, so not P and Q, that looks more like a label. Okay, so in this case, so not P and Q, we're getting false, 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 which is, of course, not what we want to get. And let's go a little bit further. I think we need a little room on the left. So we're just going to go over top of that. Okay, and then let's find the next one. And of course, we need another label. So that's going to be not P and, sorry, or not Q. Okay. And that's it. And then, of course, we want the value of that. Not P or not Q. And here, let's give us a little more room and see how that goes. All right, that got to the end. And maybe we've got a couple of extra spaces out here. Okay, that looks good. Let's see what we get. So let's give it a run. I found all the problems here, so here it is. You know what? It's very, very subtle. Okay? It is this. We forgot to use the index. Okay? So it still meant something rational to Python, which was great, but unfortunately it wasn't what we wanted it to mean. So, and then we're going to say not P index I, or not Q index I, And that's going to explain the problems that I was having. Okay, and this doesn't quite fit here. I guess I'll make a little bigger. I mean, a little smaller so we can see the whole line. Okay, so that's the line. Now let's rerun this. Let's run it again. Okay, and this is giving us the right values now. Okay, so not P and Q is giving us false, true, true, true. And then not P or not Q is giving us false, true, true, true. So these transformations using De Morgan's law, which again we do for convenience to make things more readable and understandable, we can see that they work in all cases. So again, we can either understand the law or believe the law, or we can just go and look at the truth table, the way it works out, and it works out the right way, which is good. All right, so let's do it one more time. Let's go and let's change it about. Okay, so we want the second version here. Well, we're gonna have to change a few things. What do we change? Well, De Morgan's law, second version, right? So the beginning of the line is the same. We've got P and Q. We want their values. Do we want not P and Q? No, we want not P or Q, because that's the other version of the law. So, and then we want to know what that evaluates to in Python. So we've got that. And then the other one is we want it's equal to not P and not Q. Sorry. Yeah, not P and not Q. And so then we want to come out here and change it to not P and not Q. All right. So let's give this a run. Well, we're going to give it a run, and we'll see what the results are, and we'll go to our last one. So the truth table for not P or Q goes false, 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 true. And the truth table for not P and not Q goes false, 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 true. So again, they run exactly the same. So we can either believe the rules for how these things work, or we can believe our eyes. Okay? Now, if we take this and some careful reading, we ought to do okay. Some careful thought and careful reading of problems and all that stuff, and we ought to do just fine. So let's see what we can do to clean this up. Two blank lines there, 2 blank lines here. That looks good. All right. So let's run this again. And it seems to be running just fine. Okay, and then let's go up and ask the code inspector if she likes our code. And let's see. So we've got a block comment. Oh, we've got 2 comments up here that should begin with a space, I believe. Is this it? Yeah. So I think the way to fix those is just having a space after a pound sign. So let's look at that. All right, let's code inspect it once again. and no suspicious code found. So that looks great. So that is our exploration of the rules of logic and how they work just the same way in Python, just the way the textbook says, and hopefully a little practice in using the booleans and all that stuff. So that's it for this week. I'm going to say bye until next time. Bye-bye.